Hey guys, this is a video on just basic examples of one-sided limits. So I am just going to show you how to approach these 4 examples. If you're looking for kind of a longer, more robust explanation of how one-sided limits work, I have a full 20-minute lesson on that you can totally check out if this doesn't make sense. Okay, so these are the 4 examples I'm going to go through. If there's a specific one that you want to see, you can just move ahead to it. Or you could also use this as a way to quiz yourself and then just see how much you understand. So starting with this first one, so I think it's actually important to understand sometimes why something has to be a one-sided limit. So in this example, it might be best if we have just the graph in front of us. So let's go to desmos.com real quick. So this is the super awesome desmos.com where you can just graph anything you want for free. So I went ahead and just plugged in this function. And so you can kind of see why this is an issue and why we have to have a one-sided limit here. So the reason is, so here's where x is actually equal to 2. On the left side of 2, this function does not exist. So the limit at 2 would not exist, but the limit on the right does exist. So it's actually a very easy limit to calculate, and since we know a little bit about the graph, that helps. So let me now kind of show you how to actually compute this. So we know from looking at the graph now that we're pretty safe to just plug in 2 and we're not going to have any issues. So that is, I actually don't need the limit. I can actually just plug in 2 and it's really that simple. Now, if you didn't know what the graph looks like though, so first I'll just finish this. So this is just going to equal 0. So if you didn't know what the graph looked like, what you might want to do just to confirm that this is okay to do is to just verify that this limit exists or that this function exists on the right. So what I can do is I can just draw a little table of values, and my y values will of course correspond to whatever I plug into here. And so just a few values that are on the right, so like 2.1, 2.01, 2.001. So let me plug those in real quick. So here are my values when I plug them into this function. So the closer I get to 2, you can see that this is getting smaller and smaller, and it's definitely going to 0. So this is just a good way to confirm that your limit's okay. So just in the spirit of completeness, so let's pretend for a second that we were evaluating the limit on the left. So if I tried to evaluate just any value that was on the left of 2 and close to 2, so what you would get is you would get a negative under the square root. And so for the purpose of limits, that does not exist. So while it's true that you might be able to evaluate and come up with an imaginary number, we can't put imaginary numbers on our standard graphs. So this would not exist. So this is kind of a moot point. So it does matter that it's on the right. And so sometimes you might want to do this just to kind of confirm that it's okay. So that's kind of your test for yourself. Okay, moving on. So now we move on to example B, and as far as how you would evaluate this, so this actually kind of coincides with some really standard limit tricks that we have. So if you plug this in as is, what you'll notice you'll get is a 0 over 0. So if I just kind of do that real quick, so what I would get is a 0 plus 1 minus 1 over 0, so I would get 0 over 0. So in this particular example, I cannot just plug in my numbers and be okay. Instead, what I've got to do is I've got to multiply by the conjugate. And that is a trick I've actually explained in some other videos, so you can check those out. So let's see, I've got this. So the conjugate is found by taking this expression and just flipping the sign that's in between. So I'm going to multiply the top and bottom by the conjugate, and I'm running out of space here, so sorry if it's all kind of jumbled, but I'll fix it in the next line. Okay, so pro tip here when you're working through the conjugate. As you're multiplying out the top, you want to multiply everything out together, but usually when you're multiplying out the bottom, you don't want to do that. So the reason for that is that a lot of times stuff in the bottom will cancel out. So if I multiply out the top, I get 2x squared plus 3x plus 1, and then I have minus the square root of that. I actually don't have a lot of space, so I'm just going to cut to the chase here. So the top will look like this. So I will get this plus, so I will get 1 times this, and then negative 1 times the square root. So the square roots actually drop out entirely. Now in the bottom, this is going to be x times the square root of 2x squared plus 3x plus 1 plus 1, sorry. Okay, so now I want to try to simplify this as much as I can. So I'm going to just kind of follow through with the algebra here. So I get 2x squared plus 3x over the same stuff. And then you'll notice that I can factor out from the top. I can factor out from the top. I can factor out x. So I factor out x here, and then I'm left with 2x plus 3. And so this is kind of what I mean about not multiplying out the bottom. A lot of times, not always, but a lot of times things will cancel out. So if they didn't cancel out, then maybe you'd want to try multiplying out the bottom, but you want to make that kind of a last-ditch effort or a last resort. So those x's drop out, and now this actually makes it so that I can plug in 0, which is kind of the thing I was looking for. So I have the limit now as x approaches 0, 2x plus 3 over the square root of 2x squared plus 3x plus 1, all of that plus 1. So I'm fine now to just plug in 0. So this becomes 3 over the square root of 1 plus 1, so ultimately I get 3 over 2. Now again, I can do this because I'm approaching on the right side, and you could use a table just like we did in the last example. Just to verify that this exists on the right. You would find once again that if you tried to do this on the left, it wouldn't exist. So it does matter, and you do want to kind of think about that. Okay, so moving on to this next one. So this one's a kind of a simpler example, I guess. So this is really all about just kind of knowing what the graph looks like. So if you're not sure, you can always just kind of sketch it out, because once you see the graph, usually this is pretty straightforward. So let's see, I've got 1, 2, 3. So this is a piecewise function, and it's also constant. So this says when x is 3 or above, this whole thing will equal 4. So there's what that leg looks like. You put an open circle here to indicate that this is greater than 3, but it doesn't actually equal 3. Then I've got when x is less than or equal to 3, that this whole thing will equal -2. So there's my other leg. And so this is telling me to approach 3 on the left side. So here's my point 3. So I'll kind of divide it into the left and right side. And so where are the values more negative, over here or over here? Well, it would be over here on this side. So I need to jump on this side of the function, and then as I come up to 3, well, it looks like the y value of this would equal -2. So the limit then will be just -2. And if you have the graph in front of you, that becomes the most straightforward way to approach that. So this last example has to do with absolute value, and I have actually a whole other video of just absolute value examples because I know sometimes they kind of freak people out. And this is best understood if you kind of just know the general graph of just say like the absolute value of x. So here's the absolute value of x. So it's a V shape. And so this side is -x and this side is +x, and it kind of has this like breaking point here at 0. So right at 0, then it kind of changes direction. So that is kind of the general nature of a lot of absolute value graphs. So if I just thought about, so forget about the top for a moment, if I just thought about the bottom part of this with this absolute value, at -5, I would probably anticipate like a turn. So this is just a general thing you want to make sure you keep in mind. There's a positive side and a negative side, or a negatively sloped side. So a positively sloped side and a negatively sloped side of a lot of absolute value graphs. Now, let's just take a really quick look at this particular graph just to further understand this. So I'm here at Desmos.com, which is free graphing software that you should totally use to help you study calculus. And so you'll notice here, I've plugged in our function that we're examining here. And just by looking at this, so we don't have the V here, but we do still have like this idea of a breaking off point and a change in behavior. So the thing I want you to notice is that on this side, which is where we have -5 and above, we're here at a positive constant. So this is this is +1, the constant function 1. And then from really any value from -5 and below, then we go to the negative constant function. So there's still a positive side and a negative side with our absolute value. The reason I bring all of that up is because if you understand kind of which side you're on, it actually makes the absolute value problem very simple to deal with. So in this case, am I going to be on the positive side or the negative side of my absolute value? I'm approaching -5 on the left. Well, that will actually put me on the negative side of this function. And by knowing that allows me to rewrite my whole problem like this. So I still have x plus 5 on top. But in the bottom, I can drop the absolute value and just know, since I'm on this side of the function, I'm going to be on the side that's negatively sloped. So it's actually going to look like this. And the reason why you want to be able to do this is that this will now allow you to cancel out the x plus 5s. So now I can cancel those out, and I just get that this is the limit as x approaches -5 of -1, right? And so the limit of any constant is just the constant itself. And that's exactly what we just found on the graph. So you can't make a cancellation at this step. You have to actually break this down like this. And if you're looking for more examples on that, I have a whole video where I just do examples like that. So that will cover it for this particular example video. If you have any questions, feel free to drop them in the comments, and otherwise I'll see you guys next time.